According to Charles Darwin, one of the strongest pieces of evidence favoring his theory of common descent was the remarkable similarity among animal embryos. In the late 1800s, German naturalist Ernst Haeckel produced drawings that seemed to confirm Darwin's claim.
Ernst Haeckel was a German biologist and artist, a contemporary of Darwin's, who, among other things, made some famous drawings of vertebrate embryos, fish, humans, salamanders, chicks, turtles, and so on. And in those drawings, Haeckel tried to show that all these different vertebrates look very much the same as early embryos. Their early similarities showed that they came from a common ancestor, and differences arose only later. The problem is that he faked his drawings. The early vertebrate embryos don't really look that similar at all.
The problem with Haeckel's drawings wasn't just that they were inaccurate, they were actually false in many cases. But the real damage was done when these drawings entered into biology textbooks decades ago, and they've never really been taken out. If you open a high school biology text now, or even a college biology text, you'll find these drawings, although they may not refer to them as Haeckel's drawings, and in fact, they trace their ancestry directly to Haeckel.
You see the pictures of the embryos.
And it's really damaged our understanding of development and our understanding of biology in general.
It's clear that Haeckel may have fudged his drawings somewhat to look more like his ideal than they actually are. Now, does that actually take away from what we know about the relationship of embryology to evolution? Not a bit. The whole Haeckel's embryo story has been greatly blown out of significance. It is a minor footnote in the history of science, and actually it's been known for 10 or 15 years that Haeckel's embryos are not to be relied upon. The reason why the diagrams are reproduced is because they're easily available. There's no copyright on them. It's an easy way to illustrate a point. And I would argue that the basic point that's being illustrated by those drawings is still accurate. The basic ideas that Haeckel was presenting, for example, that the more closely related two forms were, the more recently they shared a common ancestor, the more similar will be their embryology, that has held up for decades. And we have nothing but solid evidence to support that from modern day researchers as well as early 20th century researchers. A second point that Haeckel made, that within two closely related forms, earlier stages will be more similar than late stages. That has been held up over and over as well.
But if you go back earlier in development, the different classes of vertebrates look even more different.
According to Wells, Haeckel, and many modern textbooks, mislead students not just because of faked drawings, but because they leave out the earliest stages of embryonic development. What students are shown as the first stage of embryonic development is actually the mid-stage.
And very few textbooks show those earliest stages, and yet that's the whole point. It's the earliest stages that are supposed to be the most similar, and they're not. Some textbooks actually use photographs of embryos, but they pick only that stage and those classes that happen to look most similar. And they omit the earlier stages, and they omit those classes that don't look similar. So that, to me, is picking the evidence very carefully to support the theory, and that's not good science.
In 1994, journalist Jonathan Weiner published The Beak of the Finch, a book about research into finches on the Galapagos Islands. It won the Pulitzer Prize. Weiner argued that finches represent the best and most detailed demonstration to date of the power of Darwin's process of natural selection. Similar claims are made in many biology textbooks.
The Galapagos finches are a spectacular example of evolution. When the food quality, in other words, the kind of food that was available, changed as a result of a drought or a particularly rainy year or something like that, over the course of just a couple of years, they could see dramatic changes in the beak sizes in various populations. Natural selection can drive changes of a structure, like the beak, in one direction in response to selective pressure, not just fast enough, to account for what would be required for Darwin's theories, but actually 50 to 100 times faster than that.
A severe drought could cause many of the finches to die and leave only those with larger beaks. So in the following generation, the average beak size was increased. And some textbooks extrapolate this over 200 years or so and say that a few of these events strung together could transform these finches into a new species by making their beaks larger.
Look, the stuff about finch beaks is certainly interesting. Let's not confuse ourselves about that. The question is, can it be extrapolated, or does it represent cyclic variation?
What the books fail to mention is that as soon as the rains came back, the average beak size returned to normal. There was no net evolution. What we're really seeing is just one species oscillating back and forth with no real evolutionary change. So the evidence is exaggerated to make it appear to support Darwin's theory in a way that it really doesn't.
The contrary may be true. We may be seeing the development of entirely new species. The Galapagos finch starts off as a finch, and within 100 million years there'll be a Galapagos elephant. Could be. But we need a whole lot more by way of evidence than a couple of nutty journalists going down there looking at finch beaks and writing a Pulitzer Prize-winning book. A whole lot more of this is to be serious science. I mean, this doesn't even pass the threshold of anecdote. Finch beaks change in size. Yeah, they do. They change in shape, too. It seems to be correlated with seasons. There seems to be a regress back toward the mean when the seasons change again. If this is the part of a spectacular evolutionary extrapolation, let's have additional reasons for thinking that.
The changes are temporary, they oscillate back and forth, and they don't go anywhere. So, as evidence for the origin of species, Darwin's finches really don't work.
Critics of Darwin's theory say that finch beaks provide a good example of microevolution, small changes within a species or gene pool. But it does not by itself provide evidence for macroevolution, which is the origin of fundamentally new organisms and body plans.
Microevolution is what we can demonstrate in the laboratory in real time of organisms changing due to different environments. The extrapolation, to macroevolution is a quantum leap.
We look at dogs, no matter how far back we go, it's dogs. And we look at bacteria, no matter what we do, they stay bugs. They don't change in their fundamental nature. There seems to be some sort of an inherent species limitation, and we have no good explanation for this in terms of a Darwinian theory. We should have far more flexibility, far more plasticity under laboratory conditions than we actually do if Darwinian theory or anything like that were correct.
Modern Darwinian theory, known as neo-Darwinism, is based on the idea that mutations in genes provide the raw material needed for evolution to work.
Darwin's theory requires a source of new variations. And in modern Darwinian theory, that source is genetic mutation. Well, we know genetic mutation can produce changes in proteins, protein molecules. This is what leads to some cases of antibiotic resistance in bacteria. But evolution involves a lot more than changes in protein molecules. It involves changes in entire organisms, shapes of organisms, what biologists call morphology.
One of the best known examples of a mutation affecting morphology is the four-winged fruit fly.
In opening a biology text, one will often see a picture of a four-winged fruit fly. Now, as we know, ordinary fruit flies have only two wings. The four-winged fruit fly has not only its regular set of wings, but a second set of wings just next to that. And the caption or the text will say, this is evidence for the process of evolution, that mutations affect the process of development, and you can get anomalies as interesting as a four-winged fruit fly.
Gene duplications and rearrangements of genes can indeed produce very sudden genetic changes. They can produce changes that are as dramatic as a fruit fly that suddenly has an extra pair of wings or has an antenna where its eye was supposed to be. And I give those as examples not of evolution, but of the ability of the genetic toolkit to produce very sudden and dramatic changes in an organism's morphology.
Well, it turns out that the four-winged fruit fly is actually a very poor example of Darwinian evolution, certainly.
There are no muscles attached to it, so the second set of wings is effectively dead. The fly is a hopeless cripple. It's kind of like having a small plane with an extra pair of wings tied to its tail. The fly can only survive in the laboratory, and it would be selected out by natural selection in the wild. So it's not a step forward in evolution. It's an evolutionary dead end. And it turns out that all morphological mutations that we know of are either have no effect on the organism at all, no fitness effect, or they're harmful. We don't know of any that are useful.
I think this creates a real paradox for evolution. If you're going to change animal form, you've got to do it in a way that the organism can survive and can pass on those new changes. We don't have examples of these kinds of large-scale changes. It's almost as if the fruit fly says, if you want me to exist at all, I better have 2 eyes, 6 legs, 2 wings, and so on. I better have more or less the normal form